In our last meeting about projectiles, we looked at what a projectile is. We looked at the terms used under projectiles, where we also derived formulas for various aspects. We looked at the range, we looked at the maximum height, the time to reach maximum height, we looked at the time of flight, looked at maximum range, among others. Today I want us to look at how we solve problems involving projectiles. But before we go to that, let's have some hint. If a particle is projected directly or vertically upward under the influence of gravity, then it describes what we call kinematics. Kinematics is motion under gravity. But if it is projected at any angle to the horizontal, then it describes a parabolic motion, which we term as projectile motion. Let us look at examples concerning projectiles. We shall first look at the object projected upwards from ground at any angle to the horizontal. That is projectile motion. But before we start this episode, before we start looking at these examples, first watch the first episode to know how we derive these formulas, because they are the ones that we apply in working out these problems. Number 1 says a particle is projected with a velocity of 30 meters per second at any angle of elevation of 30 degrees. We are supposed to find the greatest height reached, the time of flight, and the velocity and direction of motion at a height of 4 meters on its way down. So we shall sketch our projectile motion. We are given the angle, we are given the initial velocity, and automatically we shall have the value for acceleration, which is g, because it is under the influence of gravity. So for us to get the maximum height reached, we derived the formula for the maximum height from the second equation. Or we can use the third equation, because for the second equation you must know the time. But we can use the third equation, which is v squared equals to u squared plus 2as. And at that moment of maximum height, the final velocity v equals to 0. And then u is the vertical component of velocity, which is u sine theta. So when you substitute in that, we shall get the formula as u squared sine squared theta over 2g. And we shall just substitute in the formula to get the maximum height. So it is very important not to cram, but to master these formulas before you go for projectile numbers. It is very easy if you first understand how we derive this, and it is not hard. It is just playing with the three equations of motion. That is how we shall get maximum height reached. Then the time of flight. We saw that the time of flight is twice the time taken to reach the maximum height. Therefore, it is 2u sine theta over g. Still, this is got from the first equation, which says v equals to u plus at. But v is 0 because at maximum height the final velocity is 0. So if you get v as 0, then it means that it is 0 equaling to u sine theta plus gt. Therefore, that gives us t as u sine theta over g as the time taken to reach the maximum height. But the g should be negative because it is opposing gravity. So the time for the flight is the same as 2 times the time taken to reach the maximum height. For instance, if you throw a stone and it takes 2 seconds to reach a certain height, it will definitely take other 2 seconds to come back. Therefore, the time of flight will be 4. So that is how we get the time of flight. We consider to and from. But if we get the time from going up, we automatically multiply that by 2 to get the total time of flight. So when we substitute in that, we shall get the time as 3.06 seconds. Then the range is the horizontal distance from a point of projection to point where the object lands. And we got the formula for range as u squared sine 2 theta over g. We shall still substitute for u, theta and g to get the range. The other question was asking for velocity and direction. For velocity, we say that we get the resultant velocity. So we shall get the vertical component and the horizontal component, and then we shall get the resultant velocity using the 2 components. So the vertical component is given as Vy, which equals to u sine theta minus gt. That is from the first equation. Then we shall substitute to get Vy. The horizontal component, which is Vx, that is constant, which is equal to u cos theta, because we saw that for horizontal motion, since it is constant, the acceleration is 0, and therefore we remain with u cos theta. We substitute for u and theta to get the horizontal component. From now, the 2 components, we get the average or the resultant velocity by getting the square root of Vx squared plus Vy squared. When it comes to direction, the direction is given by the arctan of Vy over Vx. And that angle is subtended to the ground, to the horizontal. Therefore, we shall have a velocity of 28.64 meters per second at an angle of 24.9 degrees to the horizontal. In our example 2, we are given a projectile which is fired with a velocity of 320 meters per second at an angle of 30 degrees to the horizontal. So we are supposed to find the time taken to reach the greatest height, the horizontal range, and the maximum range. It is very important when we get numerical problems to first read, thoroughly understand, and then summarize the given information to help us determine how we shall start working out. So from the question, we are given the initial velocity and the angle. So we are supposed to depend on these two to find what we are required to find. So for us to get the maximum height, remember at maximum height, the final velocity v equals to 0. Therefore, if we substitute in the first equation of motion, which is v equals to u plus at, our u is u sine theta because we are taking the vertical component of velocity. Then a is negative g because it is moving upwards. So when we substitute, we shall get our time as 16.31 seconds. In part 2, the range is given by the horizontal velocity times the times the time of the flight. Why time of flight? Because for us to determine the range, we must determine the range when the object lands, and by that time it lands down, it would have taken the time to go up and the time to come down. So that is time of flight. So we must first get the time of flight before we get the range. But the time of flight is twice the time taken to reach the maximum height. So we shall get the time taken to reach we have already got the time taken to reach the maximum height. We shall just double that to get the time of flight, which we shall substitute in the formula for finding the range. We have the initial velocity u, we have theta, and we have got the time of flight. So that gives us the range as 9,039.92 meters. For the maximum range, remember we had the condition for maximum range, whereby from range equals to u squared sine 2 theta, we say that for us to get the maximum range, sine 2 theta must be equal to 1, meaning that theta has to be 45. And that's why if you are throwing a stone and you want it to travel a longer distance, you normally bend. You are bending to look for the 45 degrees that could give you the maximum range. So if sine 2 theta equals to 1, then from our formula for range, which is u squared sine 2 theta, then we shall substitute sine 2 theta with a 1, which leaves us with u squared over g. We have u, we have g, so we divide to get the maximum range. Let us go to example 3, whereby we are given a projectile being fired at an angle of 60 degrees above the horizontal and strikes a building 30 meters away from point of which is 15 meters above the ground, above the point of projection. We are supposed to find the speed of projection and the velocity when it strikes the building. So if we try to sketch the projectile motion for this, it does not land, but instead it hits a building which is 15 meters above the point of projection. But the horizontal distance at any time t is given by x equals to u cos theta t. That is from the second equation, which says displacement s equals to ut plus a half g plus a half at squared. But for horizontal distance, a is 0, so it gives us s equals to ut, and the u is u cos theta times time. So from this we get t as 60 over u, and then the horizontal distance is given by u sine theta minus half gt. Still, when we substitute in this, we shall get the value of u, which we shall substitute in our first equation, which was t equals to 60 over u. So after getting u, we drive it back and substitute in to get the time. So when we substitute, we shall get the time as 2.75 seconds. And then remember, they are asking for velocity, meaning they want the resultant velocity. So in this, we must get the horizontal component of velocity and the vertical component, which will give us the resultant. So getting time will help us get the vertical component of velocity. But the horizontal component is given by u cos theta. Of course, we have already got u, so we substitute in the formula to get the horizontal component, which is 10.93 meters per second. The vertical component is u sine theta minus gt. We have already got the value for u. We have theta as 60 degrees. We have g and we have got t. So we substitute to get v as negative 8.09. So these two components will give us the resultant, and the angle is given by Vy over Vx. The arctan of Vy over Vx gives us the angle, hence the direction. And this direction is, the angle is always subtended to the horizontal. So that is how we shall solve problems concerning projectile motion. You can go and look for more, and please try out. Don't forget to share this. You like, comment. Thank you.